So you've done this factor analysis now on the structures, but the question is whether it's a good fit to the data. And it will also print in this very massive output file, you'll have something which is the RMCA and the Tucker-Lewis index. So if we go and look at a text file, somewhere at the bottom, like I've shown you all this, and then it's you'll have more output here. These are these chi-square things. You have something which is the RMCR. It also will print you the Tucker-Lewis index, which is what we're after, and the RMCA index. Yeah, these are measures of fit. Basically how well your factor model fits the data. And there's some cutoffs, and we'll come to those when we also discuss some in much more detail. But for now, you have to know that in this case, it's not a really good fit. So in my example, it's around 0.1 or something. And RMCA should be 0.06 or lower. And this Tucker-Lewis index should be over 0.9 or over 0.95, according to some. And in my example, you had 0.69. So you could check for your data to see if it's a good fit, because you all wrote it to the sync file. So you could see what the fit indices say in terms of RMCA and TLI. There's also other indices, like I already said, like RMCR, or there's also chi-squares and other values in there, but I'll discuss those when we get to structured equation models. So back to the models. The 5-factor model actually does better than the 3-factor model in this case. So if you go in my output and look for the 5-factor, if you run a 5-factor model, then you get a Tucker-Lewis index. Before, for this 3-factor solution, we had like 0.6, and here it's 0.849. Still shy of that 0.9, but it's getting closer. And the RMCA is 0.07. So 0.06 was the magical cutoff. We're slightly above that, but the 95% confidence interval just dips below the 0.06. So you would conclude in this case that the 5-factor model is also a better solution than the 3-factor model, because it does a lot better on this Tucker-Lewis index and does a lot better on this RMCA thing as well. But I'll talk more about like validating factor models when I talk about confirmatory factor analysis, and about how we can statistically compare a 1-factor solution to a 3-factor solution to a 5-factor solution when we do that. So we're close, but no cigar in this case. And if you were to write this up, you would say, that you ran a 3-factor solution, which wasn't a very good fit. But the 5-factor solution, the 5-factor model, could be considered a close fit, because the RMCA is 0.07, because that's not too far away from the 0.06. And in TLI, it's still a little bit farther off from that 0.9. So you would say perhaps it's not a good fit in terms of TLI, but it's close in RMCA. Yeah. Again, why are there more than one index? Why can't statisticians decide? Because all these other things value things differently. They value, for example, sample sizes differently, and they value, for example, the complexity of models differently. And every single measure will do so in a different way. So that's usually why people report not just one measure, but like a series of measures. And then people can make up their own minds as to whether it's a good or a bad model. Okay. I haven't dwelled too much on this, but there's many different ways in which you could extract factor models. I've done the example with min-res, but you also have principal axis factoring, weighted least squares, generalized least squares, maximum likelihood factor analysis. What you need to know is that min-res and principal axis factoring are the most commonly used. So most of the time, if you don't know what you're doing, pick one of those. If your supervisor has a very specific reason why he wants to do GLS or maximum likelihood, you can do so. Yeah. So they make different assumptions. They have different solutions, but most of the time you're going to be fine because you'll get similar results. But I would stick with min-res or principal axis factoring because they're the most commonly used in literature. So in this case, I did the same type of exercise, but now what has changed is this no longer says min-res, but it says PA for principal axis factoring. And you can already tell from this plot that it looks quite similar to what we had before in terms of a 5-factor solution. Yeah. Now we can extract all those loadings and we can try to make pretty tables. This is not the prettiest table, but we're getting somewhere. So in this case, I use Stargazer and Flyer. what we get is we can get the loadings like this. So we get the loadings from our object, from our 5-factor object. So you remember fa.values was the eigenvalues. The loadings are those loadings. So you remember for all of those items, all those 32 items, we have the loadings. And in this case, I use plier to rename the variables. So I say factor 1, factor 2, factor 3, factor 4, factor 5. If you look at the loadings, you would then, for example, call this conscientiousness, extroversion, introversion, agreeableness, which I haven't done. This is just a generic example for how you name these type of things. And what I then do is I make a Stargazer thing, and then we have something which you can see barely below that. I think is it this one? And otherwise, nope, that's not the one. What is it called? It's going to be called loadings or something. Results loadings. Okay. Okay. So you'll end up with something like this. In this case, you could replace that 1, 2, 3, 4, 5, 6, 7 with like the names of the items. So it could be distant, talkative, all those other things. I haven't bothered doing that. If all the variables are named in your data set and not item 1, item 2 to item, it's not a lot of work. Otherwise, you're going to have to do some data wrangling in order to get an even prettier table. Yeah, but it's something you report in your report. And the nice thing again is like, if you have to do this a lot with SPSFs, it would be copying and pasting to Excel or to Word and to manually edit all the layouts. Here, once you sort of have a setup, it wouldn't take you that much time to adapt it for every single factor analysis you have to do. Yeah, because you sort of know the structure in which it has to be. Yeah. So this is a very basic example. Okay, we can also plot the loadings. Again, this is not going to be visible from a distance. So we can plot all those loadings, and then you can sort of see which things cluster together. Again, you might have to zoom in quite a bit, but hopefully the things which make up the big 5 go together in those loading plots. This is way too busy, so I've just, because it did the 5 ones, so it's nearly not legible, so I just extracted one which also has just the first 2. And that's also, you can think of it as a space. Plotting a 5-dimensional space, good luck. Plotting a 2-dimensional space, slightly easier because we can still have 2 axes. 3-dimensional space, you could move it in 3 dimensions. 4-dimensional space, you need to add time. 5-dimensional space, good luck reducing it. So what you could see is like this is the first dimension, and this is the other. No, this is the first dimension. This is the other dimension. You can see the separation between conscientiousness, so you can see things persevering, hardworking, discipline. On one end of the spectrum, disorganized, lazy, and carelessness on the other side of the spectrum. And on this thing, we have the introversion, extroversion continuum. We have shy, withdrawn, distant, quiet. We have talkative, sociable, and outgoing. And in the middle, we have things which don't map onto those 2 dimensions of personality. Yeah. So what you would do is you would make a series of those plots with 5 dimensions to sort of show how these traits are laid out. Yeah. Do you understand? This is clear. So if you were to do this for your example, you would also get such a plot where you would get a separation between confidence, ratings of those teachers or instructors, and ones to do with sociability aspects if you extract 2 factors. Yeah, so this is just an illustration, and these 2 dimensions will then tell you which items separate the two factors. You can do, this was a very basic plot. It's not a GG plot, it's made in base R. If you wanted to do ggplot, you can click there and you can find out how to make those plots in ggplot. ggplot can be more versatile. You can change the font to Google fonts, the themes to all these other things. This in base R you can't do as much. So if you wanted to use those, you can click there. And what I haven't covered is you can have something which is called multiple factor analysis. You could have a group component like teachers and students. Comedians versus not comedians, so you could do a factor analysis which takes into account that groups exist, but probably you want to do more basic things like Cronbach's alpha, which I haven't talked about, which is with the thing that you you would most commonly do. Why? Because probably Cronbach's alpha is not a very good description of whether something is a reliable scale. It will be very difficult to see. So normally you would try and do factor analysis unless it's a really validated scale. So if it's a scale which has been used 1,000 times, you don't have to be the 1,001 person to establish it has 2 dimensions or 3 dimensions. So even though, so for example, I've been asked in a paper, so we used the UCLA Lowness scale, which had like, how many citations did it have, Alex? Probably thousands. Like I was asked to demonstrate it has a 1-factor solution rather than a 3 or 4-factor solution. So just occasionally people might still ask. So why don't you just report the alpha? There's issues with alpha, so don't just rely on Cronbach's alpha to sort of say, oh, it's a reliable scale. Because the same as with correlations, lots of things could be going on underneath if you reduce it to a single number. That's it for today. So your exercise consists of loading the big 5 data, like the BFI data. They live in the psych package, so you've loaded data from packages before. It contains data, so you don't have to worry about that 200 criterion. You have 2,800 participants completing items on the big 5. From the international personality pool, you'll have to subset the variables for your factor analysis because there will be some other data in there as well, which you don't need. I would like you to conduct this Bartlett's test and KMO test, which you've done the KMO test also in class. I'd like you to conduct an exploratory factor analysis using the min-risk method, and then using parallel analysis and discrete plot and discuss it as you would do. Use the very simple structure and the velocity map test as well to do those type of things to see if you recover this big 5 structure, which there should be. Extract a 5-factor model using the varimax rotation. Export the factor loadings of those 5 factors. Discuss the RMCA and TLI of that model and make a plot of those factors. And that's it. So that would be the exercise associated with this. So basically everything you've done in class, again on a different new data set. And here are some more resources. It's a big field factor analysis. And again, I'm only giving you the highlights. I have to skip through lots of things to cover everything because depending on whether you go and do experimental psychology or survey design, you're going to need one or more than the other. So I try to be keeping it broad. Any questions at this stage not related to the assessment? So if you have questions, I'll do my best to respond. In the interest of avoiding last-minute panic, I'll also post a note that 48 hours before the assessment, I will no longer answer any questions because usually people then go bananas or berserk, and it's not to anybody's benefit. So I will know. So try and plan in advance. If you leave it very late, I probably can't reply if you leave it like 12 hours before and give you a decent answer anyway. So just in order to avoid the very rare mass panic, I will no longer answer questions like 48 or 72 hours before the submission deadline. Yeah? Yes? Shoot. What? Okay. Yes. So it's looking for a progress bar somewhere. So let's have a look. Is it living in your? So this probably means that some plot is not installed. It is.
Because obviously it's utilized this.
Yes, but some plot also lives this Lavant plot, and so some plot might also live as well. So you have to sort of check if it's in there. Otherwise, it hasn't been installed because some plot might live as a package somewhere under Lavant or somewhere else. Yeah. Okay. Have you tried? Shall we try doing it again? Like,
Install it.
no, not installing, but trying knitting it again. And also make sure that it's living where it should be living, so that it's living in your root drive and not in your my documents. Some of the issues relate, unfortunately, to delete lecture 7 files because that's from the knit when it didn't work.
Wait, which one?
This
one?
Yeah. Try it again. So So the error you got was that it timed out. So either it was doing something else, which means it no longer has memory to do it, or was looking for something on the internet and then the connection dropped. You don't like that, yeah. Neither do I. But it's very temperamental. But if it works beautifully. You get some really pretty pictures. So why is it taking so what's around 17%? Why is it taking so long to do that? There's what's you got? There's a bracket missing. It just seems very slow. So here, this is what it's doing. So it's making all the spots and shipping all the things.
Why is it so long?
Because it has to fill all that quadrants and giving you. So the reason it's not like that because it has to print that to the every single time it gets interrupted, so to speak. So you need to have a look at perhaps because mine doesn't do that.
I just put the code in.
Yeah.
Well, I don't know.
Mine didn't print the same. I was getting to 86. So what's after 1991? So chunks are really more helpful than all the chunks. See towards the bottom.
Right.
The one or two up from now. Yes. So I would see what happens if that separated. Also,
Oh well.
I'm so annoyed. I'm there.
You
just get his jumpers and steal them all.
I do. And then consider removing. So the things where it doesn't like it, where you have lots of chunks, and for example, in that chunk you load slang twice. So
Because it wouldn't let me do it in Robert. For some reason. I didn't get a table or anything.
I think that was. So I think the issue is again you have to sort of see. The other issue I can see is the sync type of thing, because
I had to delete the sync because it wouldn't let me
yes.
knit if I didn't.
So if you remove all the syncs, then it will probably work. But the issue why it probably doesn't work is because there is no end sync to it.
Right.
So you don't have before. Remember, I had to say put sync with two random things to it. That will just continue to write everything except past this point.
Yeah, but so I did put it in, but then I had to remove it because I got an error saying that because of the sync, it wouldn't let me actually knit it. So as soon as I got rid of that, that error is now like.
Yes,
not
but you
there.
still have the other open sync there. So the thing above. And so what happens then if it has more closing sync is it will continue to write output to that file. And so that's probably the reason why it crashes, because it's continuing to write all those things to those text files. So I would try removing all the syncs that you have everywhere throughout.
What's that? This.
Yeah, so every single instance of sync, and then try running it again. And then have a close look again if you do need syncs, where you're going to put them on, where you're going to put them in. So you can see you have lots of, you have three syncs, and none of them have like an end sync.
Yeah.
So what R then does is like it continues to write things to the text file, but you didn't tell it to stop. with this sync thing. So the reason why probably it says I can't do any progress or anything like that anymore is because it's using all its memory to write to 3 different text files. It was writing to one, to the other, and to the next one. And so if you try running it again, and hopefully this might have helped, and otherwise we have to have a closer look. So use those things sparingly and make sure that they have like an ending, like where it needs to stop writing out of the way, because otherwise it will just continue, and then it doesn't like it because it's basically has to do lots of work, so it has to keep in memory everything. Well, we're asking to write 3 different text files at a time, like add everything, add everything to it. So, let's see if it runs and then.